So I'd like you to remember from yesterday, we talked about prisms. So when you're looking at any sort of solid and its surface area, you've got to break it down, sort of visualize it in your mind, and so turn it around and think, how many surfaces does it have, and how do I work out the area of each surface, each face? So surface area is just the sum of all the areas of the face. So if it's a rectangular prism, all the shapes are rectangles or squares. If it's a triangular prism, it's going to have rectangles and triangles in it. Trapezoidal prism has trapeziums. So we just need to know and be familiar with how to work out the areas of all these different figures. And so circle's the same. When we have a cylinder, it just means that you have a prism that has a circular cross-section. We need to work out how to work out the areas of the top and the bottom, which are circles. We know how to do that. But the problem is when we come to this curved surface, how do we approach this? So I've got this thing to show you. Yes. It's giving me problems. Come on. Okay. That's nice. Well, coming back to this then, hopefully that will work in a sec. So if you think about a cylinder, this is what a cylinder looks like. The thing I'm going to show you is unrolling the cylinder. And that's the net of a cylinder. So the important thing is, if we say, so the radius, R is the radius of the circular cross-section, H is the height, or if it's lying down the length of the cylinder. Okay, so those are the two dimensions we're interested in. So if you could draw one of these nets and just the example cylinder, so that's R, and so that's R. Okay, and then the distance between the two circles, if you think about it, the distance between the two circles is this H. So this distance here, that's H, which means that this is also H. So the height is, when we unwrap this curved surface, it's no longer curved, but it's a flat rectangle which we have placed right here. The only dimension which we need to know now is this one here. We have to somehow work out what this dimension is here. Now if you think about this, when this edge was wrapped around the circle, it was the same length as the circumference of this circle. You visualize it? When you unwrap it, if you wrap this edge around the circle again, it's the same distance as the circumference of this circle. How do we work out the circumference of this circle? 2 pi r. So in fact, the length of this is 2 pi r. And so now we know that this is radius, this dimension between the circles is h, which is the height, and then the length, if you like, of this rectangle. The other dimension is the same as the circumference, which is 2 pi r. So now we know how to find the surface area of the cylinder. We can put all these things together. We can work out the area of this circle. We can work out the area of this circle. We can work out the area of this rectangle. And we know how. Then we just add them together. So tell me, what's the area of this circle? What's the area of this circle? Radius r. Thomas? Yeah, that's right. So this one is pi r squared. Okay? And what about this one? What's the area of this thing? Pi r squared. And then what's the area of this rectangle? How do you find the area of a rectangle? Length times breadth. So you've got one length is 2 pi r, the other one's h. So the area of this rectangle is actually 2 pi r h. 2 pi r h. Because you've multiplied this, the height, by the length, which is the circumference. Okay? And so those are the dimensions, those are the areas that we need. Let me see if I can show you this. No. That's not going to happen. Okay, so those are the different areas, and we add them all together. When unrolled, the cylinder has two circular and one rectangular face. So the formula for the surface area of a cylinder is this here. 2 lots of pi r squared. Pi r squared plus pi r squared is 2 pi r squared, Adrian. And then we have 2 pi r h. So 2 pi r squared plus 2 pi r h is the surface area of a cylinder. So if you could write that down, put a box around it, this is one of the things that we need to be familiar with. And this net is very helpful to think of it. To visualize, it's like you're unrolling the cylinder and thinking about the different dimensions. Okay? So 2 pi r squared plus 2 pi r h is the surface area of a cylinder. Now, one thing we have to keep in mind is sometimes questions will ask you, what if one circle is missing, like it's an open can? Then the surface area, obviously, you have one less circle, so you have to take that into account. Or it might be a tube, just open, so you only have to work out the curved surface rather than the circles on here. Okay, so we're just mindful of the fact that you answer the question, make sure that you're taking into account which parts you're adding together and which parts you're not. Okay, so 2 pi r squared plus 2 pi r h. 2. Okay, so you can just write that down, and then I'm going to go through some examples, so I just want you to listen to that. Okay, I got the thing up, so I'll show it to you. Hang on a sec. If you have a look here, we've got a cylinder. Can you all see this? So it tells you the formula here, but the way we think about it, this is H, this is R. You take this. Okay, if you take this point and you unwrap it, you all seen this? How it's, you see how the circumference is tracing the length, the other dimensions. You see that? So it's the circumference of the circle, and when you unwrap it totally, you're left with the area of this rectangle is these dimensions and the two circles together. Alright? So you can wrap it up again and unwrap it. That's exciting. I spend hours on this stuff. No? Okay. Good. So coming back to this, if you have a look at this example, so the link to that will be on this, so you can have a look at it if you wonder about it. A cylinder has a height of 20 centimeters and a radius of 6 centimeters. What is the surface area? So it's always good, I think, to draw a little bit of a diagram to get an idea of what you're doing. So we're going to do that. So we draw this diagram, a rough diagram of a cylinder. And we mark the different dimensions. So 6 is up here, 6 centimeters, and then 20 centimeters is the height. So if we use the formula, we say, well, the surface area equals 2 pi r squared. So 2 times pi, and the radius is 6, so it's 6 squared, plus 2 pi r h. So 2 times pi times the radius, the circumference times the height. So we have 2 times pi times 6, which is the radius, times 20, which is the height. And that is equal to, make sure you all know where the pi button is. 900.17. And what's the units we have to use? What's the units, even? Square centimeters. I think it's an area. Square centimeters. Okay, because these dimensions are centimeters, but we need to, when we're finding the area, we have to make it into square centimeters. Alright, so that's the first one. Okay, so just finish writing down the working. The next thing is, we've got this one. This is a half cylinder. So what we have is, we've got a cylinder, we cut it in half, and so you've got 60 is the height, and 20 is actually this whole diameter here. So if the diameter is 20, what's the radius going to be? If the diameter is 20, the radius must be diameter and radius. We're familiar with these terms. Diameter is twice the radius. And so the diameter is the distance. This is the diameter all the way across from the center, and this is the radius. I'll make sure you're familiar with it. So if this is 20, then the radius, I'll draw it in here, must be 10. So we've got 60 is the height, 10 is the radius, 20 is the diameter. So we've got a few different faces we have to work out. What's the area of this rectangle here? The area of this rectangle. Or how do I work it out? Yeah, 60 times 20. Okay, so we're going to do that first. Area of rectangle. So it's 60 times 20, which equals 1200. That's our first 1200 centimeters square centimeters. Alright, that's the first part. Now the next thing we have to figure out is, we've got a few things we have to take into consideration. If I have half a circle on the top, a semicircle, and a semicircle on the bottom, what's the total area of those two semicircles put together? One circle, two semicircles together. So I can work out the two semicircles by just finding out. I'll just work it out as one circle. So the area equals 10 is the radius, and if I want to work out the area of a circle with a radius 10, it's just pi r squared. Pi times 10 squared. Which is equal to 314.7. 14.16. Okay, square centimeters. So now I've worked out the two circular faces. Now, if I think about, I'm going to redraw this curved surface down here. We're going to have a think about it. This is the curved surface here. This dimension is 60. I have to think about what's this length here. If it's a full cylinder, it's 2 pi r. It's the same as the circumference of the circle. If it's only a semicircle, what's the length of it? So this is a semicircular circumference, if you like. Full circle is 2 pi r. So how do I work out what a semicircular arc is? Or how do I work out what it is? What do I do? Pi r, yeah, because it's 2 pi r divided by 2. So this one, this dimension here is half a circumference. Half of the circumference so which is 2 pi r divided by 2, which equals the pi times radius. So this one here is 10 times pi, which is equal to 31.42. So this area is going to be 31.42 times 60. Okay, can you work that out? 31.42 times 60. Yeah. 1,885.2 square centimeters. Okay, so now what we have is, we've got the flat surface, we've worked out the areas of the two semicircles, we worked out the area of the curved surface, so we have to just add them all together. So that's what we're going to do now. Add that in. If we add them all together, so the surface area is equal to, first one, the first one was 1200 plus 314.16 plus 1885.2, and that is equal to what, Adrian? 3,399.36. Okay, so after a few processes, and like I've mentioned to some of you, I think, it can be a little bit of a long process. Surface area questions are a little bit tedious at times, but you just have to take it step by step. And really just sending out your working in separate categories and saying, okay, we're finding out the circular parts, doing that, finding out the curved surface, we're doing that, finding out the rectangular surface, we're doing that, and then add it all together. If you lay it out nice and neatly and logically, then it'll be easy for you to follow and easy for people marking their work to follow as well. Alright, so that's the way we approach a question like that. Now the final one is a can has a radius of 3 centimeters and a height of 12 centimeters. It's open at one end, so what is the surface area of the can? Alright, so in this case we have here. So the height is 12 centimeters, the radius is 3, but there's no top. So we only have to work out the surface area of one circle and one curved surface. This one. Oh, inside. Let's just say keep it the outside. That's a good question. What is the outside surface area? So yeah, you keep the outside, you have to work on the inside. Good question. But for the moment, let's leave it to the outside. So if we're working the outside surface area of the can, I can just say, well, the surface area is just one circle on the bottom. So it's pi times 3 squared plus the curved surface, which is 2 pi r, 2 times pi times 3 times the height, which is 12. And so that is equal to 1. Okay, so 254.47. So the careful thing here, you have to be careful of is, make sure you read the question and say it's only got one circular face. So you're not just using the formula directly, you actually have to know what you're doing, thinking there's only one circular face. There's two circular faces, maybe no circular faces to consider. Alright, so that's the way that we approach these sort of questions. And so, right, so I'm going to put my questions in. So I'll stop this.